What's up, observers? It's MR2 Healy here. I want to take a look at how the vacuum tube works with electricity and turning electricity into wireless energy, and how this is done in real world, and how this works in outer space as well. Now, what I have in my hand is a magnetron. It's from a microwave oven, and it consists of a vacuum chamber with magnets on both ends. And if you take one of these and cut it apart, you'll see what it's made of is really just a resonant chamber that resonates frequency. And this is the filament that's heated, which is called the cathode. It is heated to allow electrons to be released, or what they will be called as free electrons, are released into this vacuum chamber. And because of its shape of the veins, so-called veins inside this, creates a resonance which amplifies and or accelerates particles. Pretty much what it essentially amounts to. You can show this as an example here. Is how you can take take an ordinary handheld taser. I'll show you here. You got two of them. I got one that's ordinary that you can hit, and because the tabs are bent close enough together, we can actually get. I can't get the damn thing to focus. And if you bend those tabs apart far enough, they won't get any across it. And so what that tells you is that the air in this room is not conductive enough for the current to flow across even the difference in that much gap. So what we can do here, when you apply this gap to a vacuum, it's totally different. The energy will arc across a much greater distance under vacuum. We'll show you that here. It's two. What I have is some magnets involved here, two magnets inside. And we'll take this, and you'll see that the electricity always follows the path of least resistance, and that vacuum is less resistant than the air in this room. And we'll see that because that gap won't conduct, yet the one in there, which is larger, will. See that? And if you take a higher voltage connected to it, and we'll use this microwave oven transformer here as an example, you'll see that when I turn this on, there's not enough voltage there to jump that gap between those two wires, if you see them. But you'll have to put a dead short across them. As soon as you dead short it, though, it'll jump. It'll arc a considerable distance. However, it won't start by itself unless under a vacuum. Under a vacuum, it's less resistant, and so that's what you get. And what's happening here is the magnets this plasma is being created. There's reversing the electrons, keeping them in, kind of compacted in a tight space. And you can see nearly all the colors of the spectrum inside there. And this will actually demagnetize those balls. So I can't do it for just a few seconds. But I have some footage, some slow down footage of this, and I actually took one of these magnetron chambers and mounted inside there. We just pass the current through the resonant chamber, and you'll see that it accelerates energy in the center of this just because of its shape, literally, and the fact that a vacuum holds a lot more potential than ambient air. And also, we'll make a few videos about this, but this is how X-rays are created. If we apply around 300,000 volts to this, we we could extract X-rays from that process simply by using some sort of reflective surface. You can bounce the X-rays out of that stream off to a photographic plate. This is how they do it, an X-ray machine in a hospital. It's made basically with this same vacuum tube, in higher voltage. At any rate, you turn electricity, you're converting electricity into wireless energy through resonance, simply by passing it through a resonant chamber. This is how we've done it for years and years and years. So I thought I'd pass this one along, and I hope you all enjoy it. We'll make more of them. Peace, love, big heads up.
The Young Guide Research Station doesn't quite look like science fair. But inside is steadily under detecting life. Reports will soon flow to Mars. Heat and gigantic pressure.
Wherever there's a weak part in the spot, the lava rushes out. So the volcanic heat is huge. Unlike here on Earth, where there are surfaces that are active around plates and weak spots, this is an entire moon active hotspot.
Thanks to the incredible power of the volcanic world in the solar system.